The Mojo programming language combines the usability of Python with the performance of C. It's basically an enhanced version of Python specifically designed for artificial intelligence developers. In this course, Elliot Arledge will teach you how to use Mojo. Elliot has created many popular courses related to AI, and he's the perfect person to teach this course. Let's start learning.
Welcome to Intro to the Mojo Programming Language. In this course, you're going to learn the fundamentals of using Mojo. You're going to learn some of the intermediate and advanced features of it as well. But before I touch on those, I should cover some basics first. So you might be wondering, who the heck is this guy on your screen? Well, my name is Elliot. I'm a computer science student, undergraduate, and I like to mess around with code. I like to train language models in my free time, and I build awesome content like this. So if you end up enjoying this, feel free to subscribe. My YouTube channel is just in the link in the description, so you can totally check that out if you want. A little disclaimer, Mojo is a very new programming language. It was actually released a week or two ago, and by the time you're seeing this course may actually be out of date. So, little disclaimer there. There might be some new features, there might be some weird syntactical things that don't work the same, but this is to cover right now. There may be some new tutorials that come out in the next, few months here, or maybe even the upcoming years. So, just a little disclaimer. This may be out of date by the time you're watching this. This video was uploaded in September of 2023. So, little disclaimer there. The docs, specifically the Mojo docs, the Mojo documentation, says that this language is actually designed for experienced systems programmers. But the point of this course is to provide you with the fundamentals of using Mojo and being able to easily bounce off the documentation when needed. So, it assumes some fundamental knowledge of simple languages like Python. If you don't have any programming experience, I recommend you touch on Python a little bit, or you could even just chat GPT your way through it. That's what a lot of people do. In fact, that's what I did to learn a lot of what I know now. Understanding a programming language in depth will help you adapt to other languages as well. So if you have some knowledge from maybe C or C++, or JavaScript or Python, this course will just be even more easy for you to understand. We're not going to be doing any intensive projects. We're just going to explain how the language and the Mojo command line interface works. So we're going to be building some simple scripts. We're going to be building Jupyter notebooks using the Mojo language, and we're going to be doing some command line stuff too. This material is only backtested on Windows. All you really need is a Linux terminal like Ubuntu, and everything is the same. So this means if you're on a MacBook, for example, you could search up a little tutorial on YouTube for how to install Ubuntu and get that set up. But anyways, as long as you have Ubuntu and that little Linux environment, everything should be the same. We will be using Visual Studio Code to edit things here. Jupyter Notebooks will be in the browser. You'll see that later if you're not familiar with Jupyter Notebooks yet, but just the premise is that we'll be using VS Code as our text editor. And lastly, before we jump into what Mojo is, I want to say that for those AI enthusiasts, I'll begin with some simple sequential CPU-based processing, and then later in the course, we'll jump into some still CPU processing, but in parallel. So parallel is essentially, or at least sequential is when you do things one by one. You wait for one to complete, and you start the next. And then parallel would mean you do a bunch of tasks at the same time. So we're going to start off with some simple sequential-based processing just to understand the language, because we don't really need anything else to understand the language. We don't need super high computational speeds. We're just going to need, just some simple sequential. We'll jump into parallel processing later. So you might be wondering, what the heck is this whole Mojo thing? Maybe you clicked on it because Mojo is kind of the hype right now, but we're just assuming, you're completely new to Mojo. You don't even know what the language is about. What does it do? So essentially Mojo is kind of like it quite literally is a superset of Python. So you can use all the same Python syntax, which a little bit of limitations, of course, since it's a brand new language. And you can get the scale and performance of a language like C++. So you can use very simple syntax to write the language, and you can get insane performance out of it. So why the heck do we need insane performance? Well, the thing with Python is that Python is quite slow, actually. Python is not a compiled language, so Python takes a long time, and all of AI research right now, or most of it, is actually built and deployed with Python. So all of the models that you'll see, a lot of the machine learning courses that you'll see on YouTube and in other places are purely based on Python. So what is Mojo exactly doing? Well, it's like Python, except you're getting that speed where you're able to train models or do renders way quicker. So imagine it taking you, 4 hours to get your model to a certain prediction accuracy. Then with Mojo, if you were able to optimize around that and, put a little bit more effort into it, some key features that Mojo uses will allow you to speed up the process, and you will essentially be able to train the model in a fraction of the time. So instead of taking, say, 4 hours, it would take you maybe a few minutes if you do it right. So as advertised, Mojo has insane speedups over Python, meaning up to, I think, 77,000 times greater, 77,000 times faster than Python in some cases. And we're actually going to prove that in this video. We're going to actually walk through and show how it speeds up, and I'm going to walk you through how that all works. But anyways, this is a language to sort of revolutionize the whole AI space, to make AI way faster, to make training quicker, to make just computation in general quicker through language and the lower level optimizations. What I mean by lower level is just closer to machine code, essentially. Higher level is like more abstract, closer to English, and then lower level would be closer to binary machine code. So in case you haven't seen the actual speed up that Mojo provides, we're just going to go into the docs.modular.com. I'll actually go back here, modular.com/Mojo, and then you just click on the Mojo docs here. And then we can go to Mojo notebooks, matrix multiplication, and then just scroll all the way down. I'm going to cover this material later in the course, but just pretty much scroll all the way down. And you can see that after a bunch of optimizations, they end up with a 77,000x speed up over Python, which is insane. Like, that's almost taking an entire day of Python code running and compressing it down into just a little over a second. That's crazy. There are 86,400 seconds in a day, and if we divide that by 77,000, that means it's about 77,000 divided by 86,400 gives us that's 89% of a day. So before I even begin setting up, I want to emphasize that Mojo is a completely new programming language. It was released not even a few weeks ago, with minimal support on anywhere but the GitHub or Discord. So as for the Discord server, you're just going to go to the modular Discord server. You should be able to find it through the website here. And essentially you sign up, do your verification or whatever, and then you can actually search errors. So be like, error, for example, and then it would give you, a bunch of results. So just search up like specific keywords, be smart about it. If you're encountering like certain types of errors that are like really long, don't copy and paste the entire error into the search bar. Rather just look at like what are the keywords that this error throws, and then just paste those in and just experiment and see if anybody else has encountered that, because there are actually a lot of people in this community. If I scroll down, 2,000 members. So there's over 2,000 people in this community, a lot of which are actually offline right now. But the point is there's a lot of people that can definitely help you out, and some people that have already encountered errors. So you can totally use the Discord to search for answers or even ask questions. And the other feature that you have through Discord is if you navigate down to this Mojo section and then go to Mojo Bot Help, they actually have an AI that's trained on all of the Mojo documentation. So if you go at Kappa AI and you say, what are some basics of Mojo? I could say absolute beginner. And then it'll create a new little thread here, and it'll say stand by for 20 seconds or so. And in the meantime, I'll actually show you the GitHub. So we go to github.com/modularml. And this is everything, really. You have the Mojo programming language here. You have a bunch of issues and whatnot that you can submit to it. What I would recommend, though, is that you absolutely make sure that if you're going to be posting issues on this Mojo GitHub, that you make sure it's on fault of Mojo. Because if it's your fault, then that doesn't really help out Mojo at all, because that was just how the language was intended to work. But if you are able to verify, and you can verify through asking the Kappa AI about your issues, and even looking in the Discord, and if you happen to come across errors that are on fault of Mojo, then you can just go in the issues here. And later in the course, I'll show you how to actually post these errors and properly ask questions. So anyways, those are some of your sources for now. There's a little bit of Stack Overflow, but not that much. So your main sources are going to be little code issues, searching for answers using this Discord search bar, and asking the Kappa AI in the Mojo bot help. So if I scroll up, it says Mojo is a powerful language designed for high-performance systems programming, shares similarities with system languages like Rust and C++, but also designed to become a superset of Python. This means that many language features and concepts from Python translate nicely to Mojo, etc. And it'll give you a nice little summary. It tells you how to print stuff. You can actually copy code directly from it. It tells you how to make functions. Essentially, you could just ask it anything about Mojo, and it'll probably give you the best answer in a summarized form. And yes, you can ask it to summarize things for you. If you don't understand a systems programming concept, you can definitely just say, hey, Kappa AI, summarize this for me.
Modular and Mojo only exist on Linux machines, or at least you can only download them on Linux machines. This is a Windows machine, but I'm going to use a terminal in a Linux environment called Ubuntu. So in order to download that, go to Microsoft Store, wait for that to load. Ubuntu, awesome. Search up Ubuntu app, and then you should be able to just install it there. When we open it, I'm not going to set up Ubuntu all over again because I already have it. So just make up a username, whatever, and just do that whole process. I'm going to go ahead and open mine here. So this is the current Ubuntu that I have. It's all signed in for me. You can do clear to get rid of things. You could do ls to list all the directories that you have. You can go cd and then space ... to go back a directory, and then cd and then type in the name of the directory you want to go into. And let's just look at what we have. So I'll cd into the Elliot directory, and you can just press tab to autofill that. Awesome. So this is our Ubuntu terminal. So what exactly are we going to do next? Well, we have to make sure that we have VS Code installed. That's also really important. So if you don't have VS Code, go ahead and do that right now. Now, before we begin developing in the Mojo programming language, you're going to pop over to extensions in VS Code here, and then just simply go to Mojo like that. And you should see this verified modular creator, and you're just going to go ahead and install this. This is essentially the language support, so it'll be able to read Mojo files. Mojo files mean you can have this fire emoji, which I'll try to copy here. And yeah, essentially this fire emoji, I don't know where I can paste it into, maybe here. No, that didn't work. Anyways, you can have your file extensions as this fire emoji or the .mojo extension. Both of them work. So that's pretty cool. Unicode characters for file extensions. Gotta love it. Anyways, I'm going to go ahead and close VS Code here, and I'm going to make a new directory. I'm going to call it intro to Mojo, and I can cd into that. So you're going to go ahead and pop over to developer.modular.com/download, and this is just how you essentially get to downloading Mojo. So go download now, and then it says Mojo SDK is now available. Awesome. And here it says set up on Windows, Linux, Mac, Intel. Well, you might be wondering, why the heck did he just tell us to only use a Linux terminal, Linux environment? Well, the thing is, if we go to Windows, it's not available for Windows yet, but you can use it on a Linux container remote system. You can use that with WSL2. We're just going to use Ubuntu for a Linux environment. Same thing with Mac, right? Not available for Apple Silicon yet, but you can use a Linux system. And then to install in Linux, there's no warning there. So awesome. To install the Modular CLI, you essentially just copy this code here. I don't know if the code is different for different people, but you're just going to go ahead and copy this and paste it into the terminal here. Oh. Okay, awesome. So it's newly installed, and then what do we do after this? Well, let's actually check our modular version, so make sure it actually exists. So we have modular here. And actually another way of installing modular is to simply go sudo apt install modular. That's a different way of doing it if you'd like to do that. But this way is more guaranteed. I know some people get errors with the authentication key, so just be explicit and put this curl command. Next up, we're just going to need to install Mojo. So we go modular, install Mojo. Ooh, we found a release. Let's install it. Cool. And then we don't need the rest of this. This is already done. So I'm just going to close this out, and I'll come back when this is done. So to begin to run our first Mojo script, we're going to go ahead and open this in Visual Studio Code, or VS Code for short. And all you do is you just go code.period. The period just says open in the local directory. So I go enter, and we get it to open up in VS Code right here. So I'm not going to use this terminal anymore. I'm going to use the one built into Visual Studio Code. So to do that, if you're on Windows, you just go Control and then the grave symbol. It's right below the escape key. So awesome. We have this terminal opened up. Let's go ahead and make a new file. So we go main.mojo, and I'm just going to zoom in on here. Hopefully that's good enough. All right. It's cutting me off a little bit. Awesome, we fixed it. Cool. So in order to actually print hello world, you might be saying, can we just print out this way? And we get an error, it says to-do expressions are not yet supported at file scope. So file scope just means that it's not inside of a function or a class. So this is not inside of anything except for the file, hence it being file scope level. So this is global, and Mojo doesn't like that right now. So to counteract this, all we need to do is just go fn main. Fn is short for function. This is what functions look like in Mojo. You just go colon like that, and then print hello world. And then if you really wanted to, you could just do a variable here. You could go let x, or let hello equal hello world, and then you go ahead and print hello like that. Mojo main. And so variables do work at file scope, but we're going to dive more into that later. But anyways, we're able to print hello world. This is great. So some of you who use Jupyter notebooks might be wondering, well, how the heck do I get a Jupyter notebook running on my machine? And for those of you who don't know what a Jupyter notebook is, it's essentially just a giant notebook. It's like a white HTML notebook of a bunch of code that you can paste into code blocks and just run it in any order you want. So anyways, you're going to see what that looks like in a second. And to do that, you're going to make sure Python is installed. So make sure you go Python 3 version. Awesome. And then to install Jupyter, just go pip install Jupyter, just like that. So collecting Jupyter. As you can see, I already have a lot of the dependencies or requirements installed. So now we can simply just go Jupyter notebook, just like that. And should be able to open it up right there. So as you can see, this is what the Jupyter notebooks look like. And I can actually create a new file. We'll make sure that it's in the Mojo kernel. So you do Mojo, and then you'll see it in the top right here. If you try to open it up in the Python 3 kernel, then it will not work. So we could simply just go, for example, let x equals 3, and then we go ahead and print x. Run that. Awesome, we get 3. And then if you wanted to, you could say print x down here as well, and you would also get 3. So essentially everything carries down from the bottom, from the top all the way to the bottom. So you can store some variables up here and then just run them later down here as well. This is used for a lot of tools in data science because, or at least in data science and training models, you'll have some, trained model or something. You'll have spent a lot of compute power on training a model, and you don't just want to throw it away. You don't just want to run a single script and then just not be able to use it ever again. So you can either save model files, which is a bit slower, and you would do that with scripting, or you could use Jupyter notebooks and just save model parameters from a previous code block and then reference it again. So that's essentially what this allows you to do. And then I'm just going to delete all of these. Awesome. So this is our notebook right now. This is what it looks like. So you can choose to code along with the notebook or not. I will be using VS Code. So I'm going to go ahead and close this here. I'm going to exit. In order to cancel it, you just go Control-C like that. So that's how your Jupyter notebooks work. I'm just going to right click, delete, enter. Awesome. So that's Jupyter notebooks for you. Now we're actually going to jump into how the Mojo language itself actually works. So now let's actually begin with some variables. So what are the different types of variable declarations that exist right now? So there's let, which essentially is declaring the variable a constant. It cannot change. In programming terms, it is immutable. Immutable, cannot mutate it, cannot change it. Var means it can change. So let is constant, var is not constant. So var allows variables to be changed. Hence it being var for variable, meaning it can vary. And then we have alias, which essentially just compiles, it stores the variable at compile time. So compile time is when it's converting your code to binary form, and runtime is when it's actually just like running the code itself. So if you have variables that are stored at compile time, you might save yourself, some nanoseconds or milliseconds, whatever it ends up being. So most commonly you would end up storing what we call libraries with alias, but we'll go into libraries more later. So we have let, var, and alias. So if we go, let x equal 3, and then we were to print out x, go Mojo like that, and we get a 3 here. Awesome. What if we were to change x to 2? We can already see a red underline there. And it says expression must be mutable in assignment. So this x must be mutable, meaning it must be able to be changed. When we declare it with let, that means it's a constant. It cannot be changed. So if we change this let to a var, then boom, we get a 2. So awesome. And then if we were to just go alias, it must be mutable in assignment. So alias is essentially the equivalent of let, but for compile time rather than runtime. So var is specifically for runtime, and it allows the argument to be, it deems the argument mutable, and let deems the argument immutable, but it goes at runtime, whereas alias would be immutable at compile time. So awesome. That's essentially just all the variable declarations and information you're going to need. So next up, let's go ahead and jump into data types. So I'm just going to specifically use the let declaration here. We're going to go let x, and then you put a colon after, and there are a bunch of different data types that currently exist. So you can go, you can use a string, you can use an integer, you can use a floating point number or a float, you can use a bool, you can use a unsigned integer, and we'll go over what that means. And that's pretty much it. You have these are the 5 common data types that we're going to be using. There's one more that we're going to introduce later, but these are the basic data types that you're going to be using. So what is a string? Well, a string, we want to declare it explicitly a string, and we let that equal, and all we would do is we would put either some single quotes or double quotes around it, or even these ones, but I don't think it likes these ones very much. So we're just going to stick with single and double quotes. I like to use single quotes because you don't have to press shift when you're pressing the quote button. It's just easier that way. And you don't have 2 extra quotes to see through. Anyways, that's enough about quotes. But essentially you could just put whatever you want in here. Any word. I could literally put 1, 2, 3, and it would just say 1, 2, 3, but it's in a string form. So it wouldn't actually be like the number 1, 2, 3. It would just be like, I guess, the word 1, 2, 3, or the string 1, 2, 3, if you will. So that's strings for you. You could put, alphanumeric symbols in it, like a question mark, or like a pound symbol or a %, whatever you want. So that's what strings look like. Next up, we have integers. So integers are any counting numbers, I guess you could say that. So counting number would be like pretty much -1 to infinity, or -1, 0, 1, 3,462 or something, right? So integers are any counting number. They don't have decimal places. And you can either say int equals and then say like 6,000, or you could be explicit and say, int 8 equals 6,000. Int 8 means it occupies 8 bits on your memory. So if you actually want to calculate what the highest number is that int 8 could store, it would be 2, since it's binary bits, right? And you do 2 to the power of 8, which is 256. So this could essentially store 256 different numbers on it, or 256 combinations, if you will. That goes all the way from 0 up to, it goes from 0 all the way up to 255. So instead of 1 to 256, it would be 0 to 255, so just shift it over 1, but it's still the same amount of numbers. So if I were to do 6,000 in here, it would actually, it would not print that out. It would actually overload our int 8 quite a lot. So if we were to lower this number to say, 60, then we would get that to properly print out. Some other int bits, like bit occupying, I guess you could use, is int 16. There's an int 32 and an int 64. There is no int 128 though. So you just have 8, 16, 32, and 64. Awesome. And then if you don't want to put any number after it, it'll just default to int 64 for safety purposes. So next up, we have the, I'm going to go over actually this uint next, because it's very close to the integer. So uint, if I can type, uint, we'll just go 8, for example. I don't think you can leave it just like that. Unknown declaration must require explicit variable declarations. So that just means we have to put a number after it. We can go either 8, 16, 32, and 64. So same as int. And essentially uint, what does the u mean? Well, the u means unsigned. So if we have a variable, say, if we have an integer, it could be, -1, 0, 1, right? That would be an integer. It can be negative numbers or positive. And a uint would just be an unsigned, so it cannot have a negative or positive sign. And when we normally write out an int without a sign, say like 60, we assume that this is positive. If we go 60, plus 30,
we're assuming that both of these numbers are positive because they just don't have a sign on them. So that's what uint means. It's just only one direction. It can only go positive, whereas the int, just int without the u, could also go negative. So to your range for like an int 8, for example, would be 255 to negative 255. We could actually type that out here. 255, and we could print this out. Oh, it's going to go to -1. We go 254 maybe. 256. There we go. Okay. So yeah, 256 different ones. I got a little bit messed up there. But if we were to put, say, -256, you would also get a 0 as well. So that kind of just shows the range there. And you go uint, and I just don't think that would work. So if you were to go like maybe -1, it wouldn't like that, so it would just default to a positive number. So that's what int and uint are, just signed and unsigned integers. And then next we have the floating point number. So a float is just a decimal number. Just imagine like 60 is an integer, and then 60.01 would be a floating point number, just a float. And to declare these, we just go, we have to actually write a little number after it, how many bits it occupies, if we're going to be explicit about it. If you weren't explicit, you would just go let x equal, 3.14. 3.14. And if you wanted to be explicit about it, you would just go colon float, and then you would put however many bits you want. So you can't go 8, but you can go 16, 32, and 64. So a float 16 is just essentially like a half precision number, if you will, just lower precision. It's commonly used in machine learning for training models with like less numbers in them. So float 16 is quite useful in a lot of Mojo cases. But anyways, don't worry about that too much. That's just what these variables look like, or these data types rather. And then the last one that I like to show, go ahead and print that, get a 3.14, and then some little error there. I don't know why that is, but that's something on the Mojo end that we don't have to worry about. But yeah, now we have bool, which is the last one. So we just do bool just like that, and we assign it to bool is either a true or false variable. So just go true. We have to make sure we have a capital first letter, so it's case sensitive, or we can go false. If we were to type like 3.14, it would say, oh, cannot convert float literal to bool. So it's thinking that this is, it's thinking that you're trying to put a float here, and it's like, we don't allow that. We only allow for true or false. So bool can either be true or false. If we were to say print that out, you would get false. So awesome. That is all of the basic data types. Let's move on. So a lot of people that come from languages like Python, JavaScript, or C++, or just any other language really, you might be asking, why the heck aren't you covering arrays or lists or dictionaries? So the reason is because they simply don't exist yet in Mojo. I'll show you kind of a little bit of a cheat way to make an array, but it's not quite the same. But simply arrays just don't exist yet in Mojo. That's something that they're working on right now. So I can't really go over that because it doesn't exist. But anyways, what we're going to jump into next is how to get a user input and then just print that out, for example, because that's what a lot of you learned in Python in an introductory Python course, is how to get a user input and then print it out. So currently the simplest way to do that is to go, we're going to import the Python library, you could say. Go Python, from Python, import Python, just like that. Make sure the P is capital. And then inside of this fn main, or outside of it rather, you have to type raises. I'll go into more of why raises is needed later on, but you just need that to be there for now. Don't worry about it. And then we're going to go let pi equals python.import module, and then we would go built-ins, just like that. So essentially, we're just importing the built-ins module, which comes default in Python. If you were writing a Python script, you wouldn't actually need to import built-ins because it's already done for you. It just exists as a part of Python. So you don't really need that. But in Mojo, we need to explicitly import this. And we're just going to give it a variable name, py. Awesome. So now we can go let some, say, user input equals py.input, just like that. So input exists as a part of the built-ins module inside of Python. So we could just call input directly on that. And then we could say, what is your favorite color? And we go ahead and print out user input. Let's say your favorite color is, go Mojo, what is your favorite color? Let's say I like green. Your favorite color is green. Cool. So that's how you get user inputs in Mojo. Use the assistance of Python, which is a little bit funny, but that's currently how you do it right now in Mojo. So that's pretty cool. So now we're going to jump into if-else statements. So what the heck is an if-else statement? Well, it's simply if a condition is met, then you execute some code. And if it is not met, then you default to some other code. And I'll show you exactly what that looks like right now. So inside of our fn main, I'm just going to set a variable x. We're going to make it, let's just say an int. We're going to make it an int 16, and we're going to set that to maybe 100. Okay. So now we can actually do the if statement. We could say if x, which is what the variable name is, and then double equals. You might ask, why are we doing a double equals? Well, double equals because we're doing a comparison. So if we do a single equals up here, we are assigning the value 100 as an integer 16 to x. We're assigning the value 100 to integer 16 data type to x, to the x variable, if you will. And all we're checking is that if the value of this x is equal to 100. So this should actually should go through. So any code that you actually put under this, you have to make sure that it's indented. Same thing for like functions. I didn't cover that explicitly before, but you do need to make sure that you have indents so that Mojo knows what to, essentially how to interpret your script. So we could print out true, that. We'd get true. Awesome. So if we were to change x to say 101, we just wouldn't get anything. It would simply just say, oh, this condition is not met. This little block inside of here is not equal to true. So in other words, essentially all if looks for is if whatever this little block of code or whatever this comparison is, if it does not evaluate to true, then just skip it. And then if it does evaluate to true, then we just print whatever is indented inside of the if statement. So if you were to say do else, this would be the defaulting that would occur. So you would print failed, and you would get failed because it says this isn't true, so we're just going to default to else. If this is true, and then else, if it's not, then just default to whatever's indented inside of this else little block here. And the last one, which you may or may not use, is called elif. So you go elif just like this, and we could do another comparison. If x equals 102, then we would print, say, x is 102. So it's still 100. It's not 101. It's not 102. So it's still going to go to failed. But if we change it to, say, 101, then we would get true. If we change it to 102, we would get x is 102. And then, of course, if you wanted to add more of these elifs, you would only have an if and then an else at the bottom.
But if you wanted to have like a bunch of elifs in between, you could totally do that. So go elif x equals, say, 103. X is 103. Like, you could totally do that. You could have as many elifs as you want in here, but it does start to get redundant after a while. So that's essentially how if, elif, and else statements work. If you're wondering, like, what the heck does elif mean? That's just like a blending of the word if and else. So it's like taking the first two letters of L and then, the word if, so elif. Awesome. So that's your if statements. Let's go ahead and jump into loops next. So next up, we have loops. So what the heck are loops? Well, there's two types of loops. So there's a for loop and a while loop. A for loop will typically execute iteration by iteration until something is met, until an end goal is met, whereas while would just go on forever until something is met. So for would typically stop somewhere, whereas while would just go on forever until some conditions are met. So let's actually start off with a for loop. And a lot of you Python people have probably seen this exact sort of form before, but essentially we go for index or for iteration. And in short, we could just say for I, because it's less characters to type. And we just go for I in, and we would go range, and you could put any number here. I'm just going to put 10. And then you put your colon, indent, and we're just going to go ahead and print out I. So this is what a basic for loop will look like. I'm just going to clear this. And we get numbers printed out from 0 through 10, or 0 through 9, sorry, because it actually starts at 0 and then goes, one by one until it satisfies, a range of 10. So 10 different numbers. There's a 0 all the way through 9. So if you were to shift that over, it'd be 1 through 10. So anyways, that's what for loops look like. And I'm going to go more into how we can like play around with these later. I actually might do it after this loop part. But anyways, next up you have while loops. So what do while loops look like? Well, it's sort of the same thing as an if statement. It looks for a condition being true. So we could say, while x is, say, less than 10, we could go x plus equals 1, and we would just maybe declare x since it doesn't exist yet. We'd say let x, and then we would say maybe an integer, say maybe an int 8, int 8 equals 0. Must be mutable, so we have to change that to var. Good catch. While x is less than 10, we would do this, and then just to make sure it's working properly, we'll just print out x. So if I run that, it'll print out. It would print out 1 through 10. So it'll start at 0. It'll add 1 to x, so plus equals. You could also do minus equals, or multiply equals, or divide equals. We're just going to do plus equals for this instance. And that'll essentially just add 1 to this current value here. So it'll add 1, x will become 1, then it'll print out x, and then we see it. That's why we see the 1 first. So it looks for until this condition is met, or while x is less than 10. Once it becomes equal to 10, then we stop. So x is therefore equal to 10, then we do this last iter, and then it cuts off. And then also what you could do is you could just put a true in here, and then go, you put a little if statement inside of it saying, if x is, say, greater than or equal to 10, we would break. So what does break do? Break is essentially like extremely simple. It'll just stop the loop. So if you put break inside of any loop, it'll just stop it. And then we can actually print this out over time. So we go print x, and we would get the same behavior. So loops are a little bit more complex, but that's essentially what you have, is you have your for loops and your while loops. So I'm actually going to show a little like array, I guess, thing you could say with loops. And all we're going to do is we're going to let x, we're going to make it equal a Python object.
So in order to do that, we're going to need to actually import Python up here. So from Python, import Python object. And we're going to set this equal to, say, an array. So we'll go 2, 4, 6, 8, 10. An array is just a list of numbers wrapped in square brackets, and then each of these numbers here is assigned to an index. So 2 would be index 0. Everything starts at 0 in arrays. So 2 would be at index 0, 4 would be at index 1, 6 would be at index 2, 8 would be 3, and then 10 would be 4. So if we were to say, print x at position 3, why are we getting this? Cannot call function that would raise. Okay, so we're gonna have to add raises in here again. Ignore the raises for now, but essentially this is a Python array, and we're just printing out the third index of it. So 0, 1, 2, 3. 0, 1, 2, 3. And then a 3 is equal to 8, so we get 8. The third index is 8, so we get 8. Sorry. So that's what arrays look like, and we can iterate over these using a for loop. So we go for I in range, and then we could just say for I in x, for example, because x is actually the array itself. So we go for I in x, and then just print out I. Oh. I guess we can't do that. We can maybe go range and then length, go x dot underscore length, and then underscore underscore. Oh. Maybe that'll work. Okay, yeah. So we could go x at position I, and then we would be able to print all those out. Don't worry about this too much. This is just me taking some Python and transferring it over to Mojo. This little length thing, this len, is just short form for length, and then you put these around it because that's the method that it calls. But don't worry about this at all. This is just porting some Python stuff over to Mojo, and it's still being like mostly Python. So don't worry about this at all. This is like not part of the course. This is just me playing around with stuff. But anyways, now we can actually jump into functions. So you might be wondering about functions. And if you've done Python programming before, you've probably seen this def function. So for example, def add numbers, you pass in two function arguments, a and b. You let c equal to a and the sum of a and b, and then you return whatever c is. So if a were to equal 2 and b were to equal 5, you would say c is equal to a, which is 2, and b, which is 5. So c would be 7, and then you would return 7, which is c. So that's what Python functions or defs look like. And in Mojo, they're actually quite close. So it'd be fn, short for function, and then you would put whatever your function name is. You would wrap it in these round brackets. You would pass in your function arguments, and we'll go over these in a second here, and how you can put function arguments into it from like actually calling the function. And then you would put whatever you're going to return inside of like outside of these round brackets. So you'd put an arrow and then whatever the returned data type should be. So in this example, we go, let c equal to an integer, and that's equal to a plus b, assuming these are both integers from here. And then we would return c, which would be, again, an integer, because that's what the specified data type was. And then since we know it's an integer, we would return as an integer data type. So sort of that's the main difference between Mojo and Python is fn's or fn functions are more explicit, whereas defs are less explicit, and they would take a little bit more time because that computer actually has to like understand what you're doing rather than just having the rules just like hard to find and just like full steam ahead. So that's kind of the difference there. And so what we could do is actually go ahead and call this function. So I'm going to go fn main. We'll pass in no function arguments in here, and I'll just go add numbers, say, let x, we'll let it be an int, and we'll say add numbers, and we'll go ahead and pass in, say, 2 and 5. And then if we were to go ahead and print out what x is, we should get 7 just like that. So let's actually walk through step by step what's happening here, because to like newer programmers, this might be actually quite scary to look at. So the reason we put add numbers above here, actually if I were to put it below, you might see that, does it still work? We should actually double check that. Okay, I guess it does still work. So you can have your functions in any order, top or bottom, and Mojo will be aware of where they are. So you won't need to have something above it for Mojo to recognize that it exists. We'll just go ahead and put it back there though, because that looks better. So you have this function, add numbers. You have a parameter a, which is an integer type. It just defaults to int64 because we don't tell it how many bits to occupy. And then you have a b as well, which is also an int. We say that this function is going to return an integer type or an int64 type. And we say let c be an integer data type, meaning this is a constant. C is a constant, integer 64, and it's going to be equal to whatever the integer a and b are equal to. And then we would return c, whatever the value is, that's what you would return from the function. So you call a function, it does some operations, and then the function returns a value to its caller. So the caller, in this case, would be in our would be in our main function. So this add numbers is the caller here. We pass in 2 integers, 2 and 5. We make sure that this is a constant x, integer 64, and then we would essentially just have the output of that. So x would be equal to whatever this function returns, which would be 7, and then we could just print that out. So that's essentially how functions work on the explicit level. When you're explicit about what variables you're using, then that's how that works. So we could actually like replace all these ints with int 8. And then here as well, you could go int 8, and everything would be the same. We're going to jump into a concept called object-oriented programming. So object-oriented programming is concerned with these things called objects or classes or structs, whatever they happen to be called in the programming language. And anyways, I'm not going to philosophize about it. I'm just going to jump right into it. So the best way to really compare this is to look at what do they look like in Python and what do they look like in Mojo. So I'm going to create a new file called main.py, and this is what an object would look like in Python. So just clear this, drag it down. So what's happening here? We have a class called a banana. Actually, I'm not going to go through the class first. So initially, we have if name equals main. It'll essentially just run this main function. It's the way that Mojo works when you call this main by default. It's the same thing going on here. It just calls the main by default. So this main function is going to create a banana instance. It's going to pass in a bunch of arguments here, and then we're going to print some attribute about this banana. So what does this banana look like? Well, we have an init. So init, you could think of it as a constructor. It actually initializes the banana class. So what are we actually passing in here? Well, we have self. Self is required. We have a ripe attribute, which would be Boolean, so true or false. A length, which would be a float in Python, and a color, so a string. And these are just things that I picked out. So ripe could be like, a floating point number if you want to put it on a scale, for example. But this is just what I'm working with. So in your init or in your constructor, you would say self. You would say self dot and then all the attributes. For example, self dot ripe would be equal to this ripe argument. Self dot length. These are just the variables of the actual class itself. That's what the self dot whatever it looks like. And then you have length and color. So
these are all the variables that we're initializing for our banana class. And then if we were to say call the ripe attribute on banana, like we do here, it would essentially just return whatever ripe is. So we have a def ripe. We pass in self as a function argument because it's a def function, and then we're returning the bool value. So we return self.ripe, which happens to be a bool, so we return bool here. And then we also have, say, a length as well. I'm actually going to add the color in because I didn't add that in yet. So we go def, go color, self, and then we would return color, which is a string. So go str, and then we go return self.color. Awesome. So if I were to print, banana, which is we've created an instance of this object, so you can have as many objects as you want. And they have a bunch of different attributes, and you can just call those attributes. So we go banana dot say like color, for example. And we would just go python3 main.py. It's going to print out banana.ripe, which is false as we passed in, and then yellow, because typically the color of bananas are yellow. I don't know what type of bananas you eat. Maybe you eat red bananas, but anyways, that all works out nice and smoothly. So if you want, feel free to pause the video and just try to conceptually make sense of what this class looks like, because these are very important. Classes and objects and structs are essentially the basis of all languages, except for languages like C, which don't have them. But so in Python, this is what your object would look like, and this is just a banana object, for example. So now we're going to jump over to what does this look like in Mojo. So let's compare this side by side here. So in Python, we have a class banana. In Mojo, we have a struct banana. In Python, we initialize our variables with an init method, self, and a bunch of arguments in here with their corresponding data types. And then here we initialize our variables with self dot, and then whatever the variable is equals whatever the parameter was passed in there. You could also do lowercase, that's fine too, but I just find uppercase to be more consistent, and it's easier to read, especially for classes. I don't know. Some people like to do it differently, but that's just what I'm doing in this case. So in Mojo, you would actually define your variables here. You would say, what the variable name is, and you would say what data type it is. You don't have to declare really what it's equal to, but just that it exists, it has a name, and what data type it has. And then you would have your init method here as well. I'll go into this inout little piece here in a little bit, but this is not in the basics of the course. This is a little bit after. So you get the idea. It's sort of the same arguments in here. You have your self, ripe, length, color, self, ripe, length, color. Awesome. And then they're declared literally the same way as Python in this, this block of code is equal to the same as this block of code. And then for our little methods here, so you have, or rather functions inside of the class, you have your fn's instead of defs, ripe, and then you would pass in self, because self is essentially the object itself. So self is needed in objects, and then we say RHS because RHS is equal to right-hand side, and this is on the right-hand side. It's just kind of a common practice. You could say value or something else, but it's commonly just seen as RHS. That's typically what it ends up being. So in our def ripe, we pass in a self and we return a bool, and then we actually return the bool here. So this is what type we're going to be returning, and then we return the actual ripe variable, if you will. Here we also have this right hand side, so we pass in the banana itself, and then we say we're going to return a bool type, and then we return this ripe, which is a bool type, hence returning bool here. And then it's just kind of the same thing. It's a pattern for the rest of it. So as long as this one makes sense, as long as this init method makes sense, and these variables make sense,
Everything else below here should as well. And in order to actually create an instance of this banana, yes, you can create multiple instances. You would essentially just give it a variable. You say var or let banana equals, and you would call this struct, and you would pass in what variables or what arguments are required. So you have a ripe, which is a bool. So we'll just say false. Let's say the banana isn't ripe. And we give it a length, maybe it's 4.7 centimeters long, the float 32, and then yellow, which is a string. So we have a banana that isn't ripe, 4.7 centimeters long, and is yellow. So cool. That's how you create an instance. So you can actually go like, var, can't type, banana 2, and then you would just, you would essentially call this banana struct, and you would pass in whatever arguments are required. So hopefully that all makes sense. And if we wanted to say return the ripeness of this particular banana instance, then you would just go call banana.ripe. So this particular banana, and then you would call the ripe function on it, the ripe method, and you would pass in banana to it. So this would ultimately return let me drag this up. Banana was declared as a var but was never mutated. Consider switching to a let. So it's just giving us a warning and saying, oh, you're never really changing this instance, so you may as well just set it to a constant because variable is mutable or not constant. So we could say let, and that would resolve that warning. So awesome. We return banana.ripe and we get false. So cool. That's what objects look like in Mojo versus Python. So hopefully that is super clear now. If something didn't make sense, totally feel free to pause the video, look back, play it on half speed, even ChatGPT your way through it, because that's honestly how a lot of people learn nowadays. And it is a pretty good way to learn, is to, at least with these basic concepts, is to just plug it into GPT-4 and say, hey, I don't understand this. Or if you have a particular question about maybe the init method, like why is it called, why does it have 2 of these underscores around it, right? You could pass that into ChatGPT and say, hey, why is this a thing? And then I would hopefully be able to help you. But as for Mojo specifically, ChatGPT isn't really trained on it because its cutoff was 2021. So your best bet would just be to go to the Kappa AI in the Modular Discord and just ask it that way. So that's what I would recommend if you don't understand something, is to just ask the Kappa AI. Anyways, let's move on. So before we actually jump into importing libraries, modules, and just other people's code in general, I should let you guys know that inheritance exists in Python. Essentially, if you don't know what inheritance is, essentially it's, imagine you have a class and it's an animal. You have an animal class and you have like a dog cat, or a dog class, and maybe a cat class, maybe a giraffe class, okay? You have a bunch of animals, and then you have this one main animal class. So typically what you would do is, instead of writing all of the dog, cat, and maybe giraffe classes from scratch, you would inherit some of the attributes from the animal class. So you'd have some like general variables and some general things defined in the animal class, and then you would inherit those in those other like animal classes, so like the dog, cat, and giraffe. So that way you wouldn't have to write a bunch of code that way. So you would just inherit, and it would be less work for you. And essentially, this is actually how a lot of games work. So if you have like, different enemies, typically you would have like an enemy class, and the enemy would have some attributes like when you touch it or when you get hit by it, then you take damage, or you can do damage to it, or they only spawn in danger zones, or whatever it is. And you'd have, a bunch of subclasses that inherit from that initial enemy class that would say, oh, these are some things that are describing each different unique enemy, but it also has these general attributes that all enemies have. So that's just what inheritance is and a general overview, but it does not exist in Mojo yet, unfortunately. So we are able to create classes like these and pass in attributes to them, but we cannot actually use inheritance. We cannot inherit from other classes yet in Mojo. That does not exist. So anyways, let me get rid of this here, and we can actually begin to import some libraries. We're just going to import one. So we're going to import from Python. A lot of the libraries here, we're going to just import them from Python. So we could go from Python, not capital I, import Python, just like that. And then we would create an fn main, and we would need raises here. And I figure this is a good time to tell you exactly what raises does. So raises, essentially, you need to include it in functions that could potentially raise errors. So if you were importing a library from Python, say like NumPy, for example, some of you might be familiar with NumPy, and sometimes you might get errors importing that, or at least you might get little underlines saying, oh, what if this messes up? What if the library doesn't exist, but we're still trying to import it? Well, then you would just say, the function raises. What raises means is it can raise an error. The function is capable of raising its own error, aside of just the interpreter and compiler. So this is just super useful. I'm going to go more into depth into raises and all of these errors and exception handling a little bit later on. But essentially, it's just to say we might get errored out, but don't worry about it too much because we're sort of expecting it in a way. So we can go ahead and we could just import NumPy here. So we go let NumPy, and then we're just gonna, not that, Python, import module, and instead of built-ins like we did before, we can go NumPy, just like that. And then we can essentially create arrays with NumPy. So we go let array, ARR for short for array, NumPy dot array, and then we would put our array in it. So maybe 1, 4, 9, 16, bunch of squared numbers. And then we could just say print square root. No, we don't have to do that. We could just say print array times 2. And then we just go and do mojo main.mojo. And 1 times 2, 2, 4 times 2 is 8, 9 times 2 is 18, 16 times 2 is 32. So we actually get that returned in the NumPy array form. So that's essentially just how you import modules and libraries, is you would do from whatever and then import a certain sub object or whatever. And it's very similar to Python. As a matter of fact, it's like the syntax is the exact same, except the libraries just look different when you're importing them. And then to actually import it from Python, you would do this python.import module and then whatever it's called. So if you're going to import TensorFlow, you would put TensorFlow here. If you were to put NumPy, you would do just as we did before, and etc. So later on in the course, I'm actually going to show you how to create your own packages. So instead of just importing them from somewhere else on the internet, or somewhere else that's like downloaded a part of your Mojo, but you didn't create it, I'm going to show you how to create ones and then use them. So that's a cool little feature that Modular has been super, easy going about, I guess. It's just really easy to make your own packages in this language and in this whole modular framework thing. So I'm going to show you how to do that a little bit later, but for now, let's just jump a little bit more into what exactly does raises do. So in Mojo, we use 4 words for error handling. So as you see before, we use raises, and raises is essentially in any function that may raise an error needs to be explicitly marked with this, as we went over before. It's part of Mojo's error handling semantics. So oftentimes you're going to use this when you're importing other libraries because it may or may not work, right? You may have an error there, but most of your errors will be raised automatically by the compiler and interpreter. So don't go out of your way to just include raises in every single function. If you are getting little underlines, like red underlines, like errors, just try to include raises and then see if that changes anything. But you shouldn't need to explicitly include raises in every single function. So that's what raises does. You put that after the round brackets of a function to essentially say, this might raise an error. And then this try, except, and finally all go together. So I'm actually going to paste in some code here that I've gotten from before. So we have a function main raises, so it may or may not raise an error, and we just explicitly declare that. And then we have this try. So what does try do? Try will attempt to run some code. For example, open a file. So let's say we have some input.txt file over here, and we're trying to open it and maybe like read the contents inside. Well, what try will do is maybe we'll try to open that file. We'll try to open it. We'll create like a new resource, for example, and then open that file with the resource. And then except will look for an error, say a file encoding issue. Say our file is has some corrupt data in it. The encoding is messy, for example. And except will essentially just catch that error and say, hey, we found something, and then here's a little error reporting on what it was about. If this code fails, so it'll attempt to run it. If it's successful, it'll just go all the way through, and this except block will not be triggered. But if there is an error, then this will still finish, and we'll get a little. We can essentially raise an error. So we can do raise instead of raises. We just do raise and then error because we're raising an error, right? It kind of converts to English easily that way. And then you would just in round brackets put whatever your error reporting is. So you have an error number. You would go error number 1039 or whatever you do. Awesome. And then this finally is very important in some cases, not as important in other cases, but I'm just going to use an analogy for this. So imagine you're trying to say, you're trying to open a microphone resource. So this microphone that I have right here, let's say I want to just use it with like Mojo or something, even though it's not supported yet. Imagine we're trying to open this microphone and we're trying to record something. So we attempt to open the microphone resource, and then say we get an error with maybe there's something wrong with the microphone, who knows. So we get an error, it says something's wrong with your microphone, fix it. But what this finally does is instead of just stopping at this error and then terminating the code, finally will instead still follow through with whatever is inside of it, whatever this indented code is inside of the finally block. So if we were opening a microphone, we probably don't just want to leave it hanging. We probably don't just want to have it, go on forever and just essentially leak the microphone, right? We don't want to be leaking that resource. It leads to other errors that you don't want to deal with. And essentially finally just says, I got you covered, man. We're going to take care of that. So typically and finally, you would just essentially close that resource. So we attempt to open a resource. We say it fails. Instead of stopping there, we instead finally guarantees that we actually follow through with whatever this code is. And there we could close the file instead of having memory leaks or resource leaks. So finally is really useful there if you're taking advantage of resources. But if you're just trying to, attempt some block of code and then you see if you get an error, see if it faults, then you wouldn't really need a finally block for that. Finally would just be, when you need to run something, even though there's an error that happens. So that's kind of how that works. That's pretty cool. Very good for debugging, of course. If you're trying to, if you think your error is in, some piece of code, then you would put try around it. And then if it errors out, be like, oh, so that there's some specific thing wrong with my code. It's in that section. And then you can debug further. But yeah, if we were to instead try to close the file after it errors out, if we were to instead try to close it down here, that wouldn't work because this code isn't guaranteed to run. Once you post it, once you raise this error, essentially nothing else other than finally is allowed to execute code. So you raise this error and then immediately it says, we have an error, we cannot execute whatever this is. But finally says we're guaranteed to execute this no matter what. So hopefully that clarifies the whole error handling exception thing. What we're going to do now is we're going to go ahead and move on to some
of these function arguments like inout and some other ones that you may or may not have seen before. So what the heck are these function arguments you speak of? Well, function arguments could be one of many. There's like quite a few, meaning like 3 or 4 in this language. And the first one I'm going to cover is called inout. So what this means, we already went over functions, so I'm not going to go over that again. But essentially when you mark a function argument with inout, it means that that argument is mutable or changeable. And changes made inside of the function, so meaning changes made to, for example, a, we pass it in as a equals 4, and then we mark it with inout, and we change it to 3, then that change would also be visible to everything outside the function. So I highlight the words inside and outside because that's what inout comes from, in and out. Changes made inside the function are visible outside, inout. And then the next one is called borrowed. So let me go ahead and copy my borrowed code in here. Not really borrowed, I created it, but we use this labeler called borrowed. And this essentially just labels these explicitly immutable, meaning you cannot change them. So if we were to say do Mojo main.mojo, we initialize A and B, so we have a 4 and a 5. We call add nums on those. And let's say we were to try to change it to, let's say we were to change, A equals 3 and then B equals 2. Well, why are we getting underlines? Expression must be mutable in assignment. Okay, so what if we changed it to inout, for example? Inout. Because argument 0 must be mutable in order, so argument 0 is essentially the first one. It's catching the error on the first little function argument here in order to essentially run our code. So notice how we've declared it with let. So if we change this to var, then everything works. So we set A to 3 and B to 2, we get 5. But if we were to say set these to borrowed, then this wouldn't work because these initially are variable, meaning they can change, they are mutable, and then we explicitly label them as immutable, meaning you cannot change them inside of the function. So expression must be mutable in assignment. So essentially that's what borrow does. It says this belongs to the other function and we're not allowed to change it, even if in the other function you say that it's a var or variable. So yeah, that's inout and borrowed for you. And the next one I'd like to cover is owned. Owned is an interesting one. Owned will essentially say, with whatever variables we've labeled here, that those variables now belong to this current function. So for example, even though we initialized these variables as immutable using the let declaration, when we pass them into here using owned, it says, okay, now this function owns them, so we can do whatever we want. So this essentially takes off that little immutability feature and says we can do whatever we want to them. And if I go ahead and run this code, you'll see that. So now these actually belong to this function and they are now mutable. So if I were to say, something else like borrowed, then that wouldn't work because we're taking it from this function here. If I were to even go like that, it would say expression must be mutable because we're initializing it as let over here, which is immutable. We're trying to change it even though it cannot be changed. So essentially owned says it's just explicitly saying that this current function which owned is in, we can do whatever we want with that variable. This function now owns it. So the next statement that I want to cover is called with. So the with statement, you may have seen this in Python before, but especially in Python, with is typically used to open a file. So in Python, you would go say with
open, you would go input.txt, and you would go write, or read, sorry. And then as f, you would go say text equals f.read, and then we would print out some text. So if I were to create an input.txt, say, peekaboo, we would go ahead and run this main file, and it would open this in read mode as f or file, and we would read the file, put that in a variable, and then print that variable out. So essentially what's happening here is with is acquiring a resource, meaning files, right? We're acquiring a file read, maybe a write resource. And we want to make sure that after we're done with the resource that we dump it. So we're going to open it. We're going to use some file reading or writing resource. We're going to do some code. We're going to do something with it, and then we're going to close the resource afterwards. This isn't too common with Mojo yet. It doesn't really exist. There's essentially nothing you can really do with it right now. So I'm not going to worry about that at all. You might be asking, what is the difference between with and like a try except finally block? Well, the thing is that with by default isn't really going to run some code no matter what. So typically in the try except finally, you would attempt some code, you would potentially throw an error, and then you wouldn't do some stuff after. So my awareness of the whole with statement isn't like too in depth, but I know there's definitely some differences there in terms of how it compares to try except finally versus just with. So you could actually look into that on your free time, but we're not really going to be using with in this course at all, so don't worry about it. So next up, I want to cover something called variable scope. So in Mojo, you would typically see like, let's say x equals 3, and then you have a fn main, and you would say maybe y equals, say let y equals 4. So this is concerned with something called variable scope. So variable scope is like, you just have a variable, and then what is the scope of it? So this one would be file scope, since it's in the file. Everything else in the file can access it. If we were to go ahead and print x, we would get an output there. So this is included in all the functions. So all the functions can access like file scope, or interchangeably global variables. File scope and global scope variables are pretty much the same thing. And whereas this let y would be specifically in the function. So if I tried to, if I had a different function to, I don't know how I would show this, but essentially this is specifically only accessible to this function only. So there can't be any other functions that can access y. So if I said, if we had another function, say fn print y, and then I were to, say print y, we return that. We just keep that. Move this up, and then we were to say maybe print y will return whatever y is equal to. So it'll say unknown declaration of y, require explicit variable. So essentially saying that y cannot access this y because this y is specifically in the main function. So therefore other functions cannot access it. So this is what we call local scope. So local scope just means it's like defined to a specific function or a specific struct or something. And that's essentially what variable scope is. So if you've worked with Python before, you've probably experienced some errors with variable scope. But anyways, that's just essentially saying you can't make a variable in a function and then call it in another function without like passing in the argument of it. So that's what that is. Now let's move on to some of the tools with the Mojo Mojo command line interface, or the Mojo CLI. So if you pop over to the Mojo modular documentation here, and just scroll down to the Mojo CLI and go to, you could just essentially click on, maybe just click on Mojo, and you'll see that essentially this Mojo thing is actually a command line interface in and of itself. So we've seen that we can call Mojo files, or we can run Mojo files with just the Mojo keyword and then pass in whatever file you're running. Very similar to Python. You can use modular to, of course, update Mojo, but modular is not really the focus of this. It's more like Mojo commands. So Mojo run builds and executes a Mojo file. I won't be really using this much because it's not as important. But what is important is this little build command here, and this will actually accelerate your speed by quite a bit, not by like 5-10x. It might, but it honestly depends on what you're doing. Anyways, let's just cut to the chase, and I'm going to show you what build does. Let's actually use this Mojo build command. So I've just ported some code that I've written to essentially test PyTorch on both CPU and GPU. So we went over sequential processing and parallel processing. This is essentially just doing that, and we're just comparing speeds. So this is probably scary to look at first, but essentially if I do Mojo main.mojo, I give it a second. CUDA. Okay. And we get a CPU time. A lot of this time is spent actually importing the packages itself. So some of this is going to be spent, so some of it is going to be spent on CUDA time as well. So CPU actually performed almost 5x better than the CUDA time, which is insane. And if I want to instead build, if I want to instead build this into a binary form and then run it, which should be faster, I would just go Mojo build and then main.mojo, just like that. And we should see main binary file pop up. In order to run this, we would just go /main. We can see that we get a CUDA 1.2 seconds, or sorry, CPU 1.2 seconds, and CUDA is sped up by quite a bit. So this sort of just proves that normally running Mojo in this way is less efficient, or less quick rather, than making a binary file using the build command. So if you're just testing around and playing with things in Mojo, you shouldn't really need to build it. But once you're ready to push it and really see what the limits are of that file, and to see how fast can this possibly go, then you would want to use the build. So if you're pushing something to production, or you just want to, say in the future, you're able to train some neural network and you want to go as fast as possible, you might want to use the build command rather than just running it normally. So anyways, that's how that works. It's fairly simple. You just build this, and then you do / and then whatever the name is. In this case, it's main. So awesome. That's how that works. Now we're actually going to go into how you can build your own package. So for example, Python we're able to import it. It counts as its own module or library or package, or whatever you want to call it. And we're just going to create our own. We're going to create some object or class or struct, and we're going to import it into a different script, even though it exists on a completely different place on the computer. So we want to build a package just to maybe use later. And so first of all, we're going to have to go to the docs. I skipped ahead a little bit there, but essentially you go to Mojo, and then I might just full screen this for a second. Mojo CLI, and we go to Mojo package, and then so there's a whole description here about just some extra options you can pass into it. But what we really care about is see more about modules and packages. So let's go ahead and click on this. I'm going to drag this over to like a split screen, and we're just going to follow the instructions. So it provides a packaging system that allows you to organize and compile code libraries into importable files. So when you like import Python, for instance, you go from Python import Python, and then you can use some of the built-in libraries. It's essentially like that, except we're making our own libraries. Introduces necessary concepts, blah, 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 and to understand, you need to understand Mojo modules. So single source file that includes code suitable for use by other files that import it. So you can create a module to define a struct such as this one. So let's go ahead and follow along. I'm going to go ahead and actually we're going to scroll down just to make sure we have the structure correct, because there's a structure down here that we're supposed to follow. So we go make a new directory. We call it maybe my package, and then we make a new file inside of it. We go init.mojo, and then we make a my module .mojo. Awesome. And then we have our main here. So awesome. These are all empty. What do we put in them next? So we have this my module.mojo here. So we'll just pop this in, and let's first look at what this does. So this is a struct. We have some variables, 2 integers. Essentially, we're just making a pair, hence it being called my pair. Those are essentially just the instance arguments that we're going to pass in when we call this with our package. So awesome. Now what? Now we have a main.mojo. So we're going to have to actually import from this. We're going to have to go my package. You're going to see this. A crash happened in the Mojo parser. So I can actually go ahead and run this main.mojo, and we're getting aborted. This is currently still something that Mojo is figuring out right now. I was running into this error quite a little bit, and we're just going to sort of go full steam ahead, and we're going to go to the end result that we actually want. We're not going to be concerned about this for too long. So, for example, import something that's in the same directory. So essentially what's happening when we import this, we have from, so it's going to come from somewhere else. So it's going to come from the my package directory dot my module. So it's going to come from my package dot my module, and we're going to import my pair. So that's exactly what this, like quite literally what this says, from my package dot my module, import my pair. And so this should work fine. And really all we have to do to fill in the blanks here is essentially just create, we're going to create a package out of this. And you can leave the init.mojo. You don't have to edit this at all. So essentially how this goes is we just go Mojo package, and then we look at whatever the name of this package is called. Just say my package. We're going to do -o, and then whatever name we want it to be. Just be like maybe test pack. Oh, testpack.mojo package. And you have a nice little Unicode character here as well, which is really cute. So just a .mojo package file extension. Then we can go ahead and create that, and we see that it shows up here. So in order to actually import this into our main.mojo now, we see that it's in the same directory. It's in the same local directory as main.mojo. So these are together. So we don't need to like import from something, far out. All we can do is essentially just we can go from testpack.mymodule, because keep in mind it's still going into this my module instead of my pack, but this is just compressed into like a shorter form. So if we go ahead and run main.mojo now, we should see main.mojo, we get 2 and 4. We passed in the pair 2 and 4, and we get that output. So that's really it. That's honestly how you make packages. Just you make sure that you create a directory in the local folder, and then you put an init mojo. It has to have 2 underscores on both sides, and then whatever your module name is called, and then you do whatever you need to in here, maybe a struct, maybe a few structs if you want. And that's pretty much it. So that's how you create packages. So we just covered two of the command line tools that Mojo uses. So Mojo build and Mojo package. So if we want to actually look at some others, we could just go down to Mojo here, and we can see that we have run, build, which we already did, REPL. That's not something I'm going to cover in this video. We just did package. Formats, I don't think this is as important. Docs, I haven't seen a lot of usage with like demangle doc format. A little bit of REPL, but just for like the basics and creating your own packages and building binary executable files, build and package are going to be your best bets. If you want to, you could totally dive into other commands, but those are the only that I feel like are very necessary for the basics. Anyways, you should give yourself a pat on the back. You made it really far, and there's actually only a few more concepts we have to cover. There's not that much. You're like almost done. So give yourself a pat on the back, grab some coffee or whatever you do, and let's jump right back into it. So I want to introduce the coolest data type ever. It's called a SIMD. So what does SIMD stand for? What is this SIMD? What does it mean? Well, SIMD is short for single instruction, multiple data. So that means you can have, say, an array, and instead of doing an operation on each element in the array, you just do one on everything. So it's only one operation. So what does this actually look like if we were to, say, use Python? So in Python, you'd have like an array, say maybe 2, 4, 6, 8, or 2, 4. And essentially, you would have to loop through this entire array and do an operation to each element. Let's just say we're multiplying by 2. So you'd have to go through each element. You'd go to the first index. You would set the new you'd set a new array to equal what is this times 2, and then what is this times 2, and then what is 6 times 2, and then what is 8 times 2. You would do all of this sequentially. But SIMD is different. So you can just do times 2 one time. You multiply the entire thing by 2, and it's done. Just like that in one operation. It's essentially a CPU instruction. So it's an easy way to write it, but essentially CPUs accept a certain type of instruction, but CPUs will accept some instructions that will allow them to take like shortcuts and loopholes around things. So SIMD is an example of that, where you don't have to iteratively multiply or add things together. You could just do it all at once in one operation. So for example, if I were to print, say, x, which is this SIMD, and then I multiply by 2, I could run this, and we would get essentially everything multiplied by 2. And this all happened in a singular operation. So next up, there's an interesting, I guess, method you could say we could call on the SIMD type, which is len. So len is equivalent to essentially length of x in Python. That's what it would look like. But in Mojo, we would do x.len and then just some round brackets. So this will print out 4 because we made the length of it 4. And this is a good time to actually delve into what each of these parameters are. So first of all, you initialize a variable, say let x equals, and then we could just say it's equal to a single instruction, multiple data, data type, and then we have some square brackets here. And inside of these square brackets, you're going to pass in the data type that you desire it to be and the length of this multiple data, if you will. And so to do that, we use dtype and then dot whatever you want. It has this data type needs to have a lowercase letter. So you can't do like float 16. It has to be a lowercase letter. And then this 4 is essentially just how long it's going to be, because it's one dimensional. It's just like one dimension. So after these square brackets, you just have these round brackets here, and this is the contents of what you want. And there's an interesting thing we can do with these, because consider this is 4 elements here, and we explicitly declare that this is going to be 4 elements long. So what happens if we add a 5th in, say 25? and then we print out what is x multiplied by 2. We get this number, we get this SIMD returned back. So this essentially means that we're going to take the first 4 numbers of whatever you put in here, and then everything else we're just going to splice it off. So that's a cool little feature. I don't know if that's a feature or a bug, but I think that's pretty cool how you don't get errors for doing that. So anyways, there's a lot of operations you can do with these. There's certain ways to make like a really long, what we call vector, that's just the same exact number all the way through. And this actually leads me into a little bit more deep dive of what this SIMD type is. So let me go ahead and just get rid of this, and I'm going to copy some code in. So we have a function add and we have a function main. Now don't get scared by this too early. So what is this function main going to call? Well, we're going to let x equal the SIMD type float 16. It's literally the same one we just used, and we're gonna pass it into a function called add. So x and x. So what's actually happening in this add function? Well, first of all, we have some square brackets here. This is going to determine what the data type is and what the length is. So these are the two essentially needed function arguments for operating with SIMD types. So you would essentially give a name for what the data type is. So D type, we would give that data type. And then the length, we would just set that to the data type int. It could be like an int 32, int 64. Doesn't really matter. We're just saying that it's going to be an int here. So this is like converting your data types to names that we can use later. Now we have these round brackets, and notice how these actually stretch out quite far. So in here, we specify the actual function arguments themselves. What is this first x going to be? That's going to be a. It's going to be this piece right here. So a is going to be a SIMD type with data type D type and length of type integer. And then same thing for b here, except we can't just, we simply can't have a twice, because that would give us errors. So we're just going to do a and b. So next up we have, we're essentially just returning what this entire function is going to return, which of course has to be a SIMD type with data type, D type, and integer. So that's that. That's a lot of content, but essentially all that really happens is we just add them together. It's a single operation that we do. And if I go ahead and run this here, we will get this. I mean, we could even multiply them together. We could even multiply them. 1 times 1, 4 times 4, 9 times 9, and 16 times 16. We could even divide them if you want, since they're a float 16. So everything divides by itself, or if something divides by itself, it's equal to 1. So that's why we have 1s there. But anyways, these instructions are super cool. I'm not going to dive like an insanely amount more into them, but we're going to use SIMD types a little bit later on to do some speed tests. But before we jump into that, I want to cover some other concepts and topics. The next one being decorators and metaprogramming. So I've just kind of implemented, it doesn't really do anything, but this is what it looks like. This is called a decorator. And decorators come from a practice called metaprogramming, where metaprogramming implementations look at the code architecture you've attached the implementations to and have the code optimize itself based on the specific metaprogramming feature you're using. So in the context of unroll, essentially what this does is it unrolls the loop. You have some loop, and it unrolls it into a bunch of individual iterations, if you will. So if we're looping over this 10 times, if we're doing I 10 times, instead of going sequentially, it'll split it out into 10 different individual loops that it'll, individual iterations that it'll do. And so we can even pass parameters into unroll. We could go, for example, 2. And what 2 would do is it would split it into iterations of 2 and loop over 5 times. So there's a bunch of ways that you can mess around with these metaprogramming features. They make everything super hackable, hence the word metaprogramming. It's a beautiful word. And this essentially allows you to take advantage of maybe parallelizing some operations. Maybe you have a loop where instead of sequentially running it, you want to split it into a bunch of individual iterations and then plug, say a fraction of them into each processor that you have and have it done in a fraction of the time. So little optimizations like this will greatly help performance, but metaprogramming has always been sort of an advanced feature. So I thought I'd share with you what exactly they look like and an example of what one of them does, meaning unroll. But they are an advanced feature, so I'm not going to go super into it this video. However, if you are interested and wanted to dive deeper into decorators and metaprogramming, I would highly recommend that you refer to the documentation. So let me now show you the case for an up to 77,000x speedup over Python. It's blown a lot of people's minds in the past little bit, but so if we just go to the modular documentation here, just docs and then Mojo notebooks, matrix multiplication in Mojo, just scroll to the top. I'm not going to walk through like the actual matrix multiplication that's going on. The algorithm here isn't important. The fact of the matter is that we just need to plug these code blocks in and see how it progresses based on what features we add to it and what optimizations we add. So what I've done is I've ported all of this code block by block all into, and you can see they have a 77,000x speedup, and I've ported all of this into my own notebook here. So I've already run everything, and as you can see, initially we get 0.001 gigaflops, and then after an optimization we get 0.01 gigaflops, which is an 8x speedup, and then like everything here is compared to the original, by the way. So everything is compared to the first 3 code blocks. So we get an 8x speedup and a 3000x speedup, and I'll go into what exactly is making it go up to 3000x, and then a 13,000x, a little bit more, and then a 22,000x, and then 19,000 just due to some hardware stuff. It could go up or down depending on your hardware. And then it just kind of settles around a 20,000x speedup. And this is just for my machine. Again, the modular team probably tested it on a machine that was favoring this code that they used. So there might be other ways to optimize around your own machinery, but that's not something you should worry about as a beginner. All you should worry about is what are the fundamental concepts and practices you can use to get the most significant speed up without overcomplicating your entire thing. So if you can get like a 5000x speed up and it takes you 5 minutes to implement it, maybe just stick with that. Maybe you don't even have to go to, a 10,000x speed up, because that's just making it twice as efficient. It's not as big as a 5000x jump. So anyways, I'm going to walk through this, sort of what's happening here. So initially, we're using Python to do a matrix multiplication. And the thing with Python is that it's not very good at running code on multiple CPU processors. So if we actually look, I can check my current CPU processors. If I go to performance, we go to CPU, and it'll just say logical processors here, or your threads. Logical processors and threads are used interchangeably. So you can see what your number is there. And that's essentially how many processors can do computations in parallel. So initially, Python is only using one of those 12 threads. and then what we do afterwards through this next jump, let's take a look and see what it's doing. So what this appears to be is instead of using all Python, we're actually jumping over to some Mojo syntax. So we're using fn's and we're being more explicit about what types we're giving things. So we're being more explicit. We're getting more to the point about what exactly the code is trying to accomplish. And then I'll just navigate back here because it's hard to follow along when everything is black and white. So initially we use one processor, and then we use some modules from Mojo, and we use some Mojo-based kind of syntax. We do some importations here. Then what? Then we add types. Okay. So yeah, just adding types in is going to give us significant speed up. And then we have a benchmark function, which is built into Mojo, and it's used to just sort of do speed tests like these, do benchmarks. So now we get into the cooler stuff that I actually enjoy talking about. So one is vectorizing. What the heck is vectorizing? So imagine you have, you're in a, I mean, some of you have probably taken introductory physics before or something close, maybe a science class. And so when you think of a vector, you think of a direction and a magnitude. A scalar is just a magnitude, but vector has a direction with it as well. So, for example, if you were say had a velocity, maybe you'd be going 10 meters per second at this amount of this amount of degrees, right? So you'd have some direction and a speed at which you're going in that direction. So that'd be a vector. So some ways to actually store that would be maybe an x attribute. So if you have your little hypotenuse here, you have an x attribute and a y attribute. So you have your x as 1 in your 0th index, and then you have your y attribute in the first index, and then you have maybe your direction in the second index. And if you wanted to increase the dimensionality of this, meaning if you wanted to, instead of just have 2 dimensions, you could go to 3, so you're having vectors in 3D space, or you could just increase it up to like 10D or 100D, whatever you wanted to. And essentially vectors are ways to describe essentially direction and magnitudes in any dimensional space. So with vectorizing, we essentially convert things to the SIMD type. And this allows us to do these matrix multiplications with far less operations. So I was talking about the SIMD types before, and we're essentially just treating our vectors as SIMD types and then working with those. So that's what vectorizing is, converting to something that you can do one operation on that's going to scale up computationally wise. And we can see that we get an insane speed up there. So 1,600 all the way to 7,000. So we've just sped up this a ton just by using vectors. Then what's next? So parallelizing. So you might think parallelizing has to do with the GPU, but in this case, it doesn't actually. What parallelizing does is instead of just using one thread, we're going to be using maybe not all 12, but pretty close, like maybe 10 or maybe 8 of them, or maybe 11, who knows. We'll be using a lot more of these threads or logical processors essentially in parallel. So imagine you have a giant piece of data and you have 4 processors that can go through it. So instead of having one processor or each of them go through the same amount of data just from the start all the way to the end, what you do instead is you give them each little jobs. So the first processor can do the first quarter, second processor, second quarter, third processor, third quarter, and etc. And you split it into jobs, and what ends up happening is everything is run at the same time. All the processors are run at the same time, and each of them complete their jobs at the same time because these lists or these pieces of data you have to sort through are now a quarter in size in comparison to the entire length. So now you've just essentially decreased your total runtime by a quarter just by having 4 processors that you're running things on. So based on the number of processors that Mojo is allowed to access, this is governed by the operating system and some other features I'm not going to get into. But essentially, that's what parallelizing is splitting a task among a bunch of processors instead of doing the entire thing on one. So with parallelizing, we go from 6,800 all the way up to 62,000. So in this case, they probably had a lot of processors that were being utilized to get this 10x speed up compared to about 6,000x speed up. And then the last one that's quite interesting is called tiling. So tiling is an interesting one. The best way to sort of conceptualize this is to think of a giant grid of numbers, like a giant 2x2, like a times table, if you will. A giant 2x2 times table. And instead of calculating everything all at once, and this might not be like a 10x10 times table. This might be like a 500 by 500 times table, or even way larger than that. So what tiling allows you to do is, instead of doing everything at once and drawing it from your RAM, your slow memory, it will cache it in your CPU. Your CPU has little RAM chips that are way higher bandwidth, and they allow information to be transferred almost instantaneously. So what this allows you to do is essentially load in little bits of this times table at a time so that you can do computations on them. So say you want the first 5 numbers, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you got 5 times 5 there. You've got essentially 25 boxes that you're going to do instead of, say, 2 million or 2.5 million, or there's some crazy number. And you can load these into your caches, your CPU caches, preemptively. So you don't have to do this right away, or else that would essentially degrade away at your runtime, constantly having to move things into your cache and then use them. That just adds on to extra time. So the compiler could be smart and instead move over what it knows it's going to need before it has to use it. And then once it's actually asked to do those computations, it can very quickly draw from that little cache and then get the next one in so that it's ready to do the next computation. So this way you're saving time from avoiding that giant delay and drawing all of that information from your RAM, and rather just having it ready in your CPU caches. And to look at those, we can see our CPU caches. We have an L1, L2, L3. So your L3 would be the slowest. L2 would be a little bit faster than L3. And then your L1 is like extreme speed. Like, this is almost incomprehensibly fast. And so probably a lot of these this tiling operations are going to be stored on your L1, L2, maybe L3 cache. So that's kind of just what's happening with tiling when we do matrix multiplication. It's like storing times tables in little tiles, essentially, hence it being called tiling. And that way you're saving the memory draw time, the transfer time. So that's vectorizing, parallelizing, and tiling for you. So hopefully that all made sense. If it didn't, totally ChatGPT your way through it, man. I totally encourage you guys to use generative AI to help understand this stuff better. It's such an amazing tool. But anyways, that pretty much sums up everything that this course covers. So bear with me. I'm going to do a little outro here with some more little facts and stuff that you may want to know about the language. And so next up, I'm going to walk through how to report errors. And actually, before you actually report any errors, there's a lot of things you have to check over first. So one, actually just go to the Mojo bot help and then type, Kappa AI, I have a problem. And then it'll open up a new thread, and you can ask it questions just by tagging it through the @ symbol. So Kappa AI has essentially memorized all of the Mojo docs and knows everything about modular. So you can just bombard your questions with it. It's not a human. So there's that. And then also being able to search through errors through this search bar, this is a huge help. So what if I say like environment variable, and then I get a bunch of, I can go new, old, or relevant, and get a bunch of data about how do I read environment variables in Mojo, right? Like there's a bunch of comments here. So you might be able to find your error. Maybe someone else has already ran into it and they've gotten an answer, or you can collaborate with somebody else in this Discord server. So this will be in the GitHub repository. And also you want to make sure, I'm going to go to github.com. We're going to go to Mojo, and if you're actually looking at an error, what you want to make sure is that you check issues, because there's a lot of errors that have been asked here. There's actually like a lot of pages of errors. So what you might want to do is just take a quick scroll through these and just look for any keywords. Say, maybe I can't access environment variables, and you go to the next page, and then nothing is found here, right? And you keep going through your pages and just look for your keyword essentially to see if anybody has ran into this problem before, and to see if it has been answered. So that way you're not just bombarding this whole issues page with the same error twice. Because if you have the same error twice, then that means they have to, that's a little bit of a hassle for the modular team. And you don't want that, because you want a good programming language faster. So just be cautious about that. It shouldn't be too hard to look through and just see if errors have existed yet. Just look through the GitHub, look through Stack Overflow, look through the Discord server, ask the Kappa AI, and then your last resort is probably going to be if it's at fault of Mojo. So if it's not your fault, it might be Mojo's fault, and it's something that nobody has asked yet, and you actually need to propose an error or a question. So a few key points that are very important when you're asking a question. So you need to be specific. So clearly state what you're trying to achieve, where you're facing issues. Secondly, you want to show effort, indicate what you've already tried. So include some relevant code or error messages. So you want to have full information. Be respectful. So you want to be polite and appreciative, because these are other people that are taking time out of their day to potentially help you. So you want to just be respectful and show that you care and aren't just trying to care only about yourself. You also want to use descriptive titles, because when these developers and debuggers are going through and they're looking at all the titles, they want it to be something that's easy to read, something that they can make sense of. If it's like, just a bunch of random characters, it's like, maybe that person doesn't quite know how to ask about errors. And so that's going to be harder for them to approach because they don't know what's going on. So you want to address the issue or question within your title. You want to keep it relevant, so stick to the main topic and avoid any unnecessary details. Make sure everything is formatted properly. I'm going to show you how to do that in a second here, how to make sure your code and logs are formatted properly. You want to also include some system and platform details. So since this is closer to a systems programming language, you want to include some information about your system, such as maybe your RAM, maybe just some other aspects that might affect the reason you're getting an error. So anything that could be remotely close to that, you want to make sure you have full information once again. And lastly, avoid emotional language. Don't get mad. Don't swear. So just be super polite about it, and don't get like mad or anything. I mean, we're all developers here. We're all on the same page. We're trying to make a better community for the development of artificial intelligence systems. So don't get mad. Just take a chill pill if you can. And yeah. So anyways, I'm going to walk you through how to actually submit errors. So here are some examples of both good and bad examples. So if you're on GitHub and you're trying to propose an issue, you go new issue, you say title. A bad example would be software keeps crashing ... and then your software sucks, fix it, am getting compiler error. So first of all, the title is misleading. It doesn't really give any information about it. It's a little bit disrespectful because you're not considering what it looks like from their perspective. Your software sucks. That's like, you don't need that. Fix it. It's hard to know what to fix if you don't give any details. And getting compiler error, well, you need to spell things correctly, first of all. And just getting compiler error could mean anything. There's like billions of compiler errors that probably exist. So don't go down that route. Instead, what a good example would be unable to save settings in a version 2.1.4. So it's showing like a version specifically that you're getting errors in, and then just something around saving settings. And then maybe your body would look something like, hello, first of all, thanks for the great software. So you're like, oh, this software's great. You're being polite. I recently updated to, version 1.2.3 or 2.1.4, and notice I can't save my settings anymore. Every time I click save, the software crashes. And then maybe you would provide some steps to reproduce. So, open software, go to settings, change any setting, click on save. So this way that developers can reproduce the error. If other developers are able to reproduce your error, then it's easier for them to pinpoint where it's going wrong. Because if it's working normally for everybody else and not you, then if you can show a way where they could get the same thing as you, then they can compare what's working to what's not working and try to mess with things in between to get to a breaking point where it works and then doesn't work because of maybe one line or something. So that's really useful. And then what your expected result maybe was, right? Expected result, you don't always need to put it there, but it's still a good practice. And then your actual result is, whatever error you get. Some system information as well, like maybe your operating system. For example, if you tried to install Mojo on a MacBook and you didn't have the Linux terminal, if you just used the Mac terminal, of course you're going to get errors because it doesn't support Mac OS yet. So system information is always good to have. And then just, be polite. Any help would be appreciated. Thanks. So that's a wonderful example. And even if you wanted to, you could also consider maybe just putting some quotes around things. So let's say steps to reproduce. You put 3 quotes around it like that. And we should, when we submit this issue, I'll actually go just to show you guys what that looks like. So when you put the 3 quotes, both on the top and bottom of something, then you get this. And then if you put single quotes, we're talking about these things, by the way, not these, just the grave. And essentially those quotes are going to allow you to make little code blocks in here that people can copy and paste from. So this takes a little bit of practice. You can create your own GitHub repositories and practice it on your own. But this is generally what it's supposed to look like. It's supposed to be very clear. You would probably include your logs in the form of this, and then maybe some code that you have in the form of this, like where your line is erroring out. So since Mojo is kind of an AI-derived language, it's used for accelerating a lot of these artificial intelligence systems through just faster computing. So a big question is since it's so early, a lot of people are wondering if you can actually build and train neural networks in Mojo. So I can't really say yes or no to this, but if you were to use something like, say, TensorFlow, that wouldn't work quite, or TensorFlow or PyTorch, that wouldn't work quite as well because you depend on a lot of things like file read and writing, inheritance, maybe lambda functions, arrays, whatever, which just doesn't exist yet. So technically, if you want to go the easy route and use a lot of the Pythonic libraries, that wouldn't work. However, there are still some people building some pretty cool projects right now that are more like a lower level, like they kind of look like C++ code a little bit. So they're not as Pythonic, if you will. And I'll actually leave a project like that in the description. Somebody actually was able to build, or at least attempt building, the Llama 2 model using Mojo. So that's cool. That's just going to be in the GitHub repo in the description. So feel free to check that out. The other point is that since we cannot read and write to files, there would be no point in actually doing a lot of this training. So we would have to rely on third parties like Python to do this read and writing and saving the actual model files for us. Or else what's the point in even training, right? If you have a script that trains a model and then just dumps all the parameters after, then I mean, you maybe used it one time, maybe you prompt the model once, but that's just a lot of wasted computation. So we want to be able to save the model files so that we can use them again. And that's just not super compatible with plain Mojo right now. So my answer right now is like no. For beginners, you should not attempt to build any neural networks from scratch or anything, or even use Pythonic frameworks. So for now, my answer is no. And I should probably add to that, meaning like what doesn't exist yet in the Mojo language. If neural networks don't really exist, they kind of do, but they also kind of don't. What doesn't exist yet? So you have list comprehensions like arrays, dictionaries, etc. You have lambda functions from Python. Those don't exist yet. Struct inheritance. You would see something like this with PyTorch and inheriting nn.module, if any of you have worked with PyTorch before. So you can't really keep track of your gradients that way. And then again, file read and write does not exist yet. So there might be a few other things that I maybe didn't cover, but those are kind of the huge ones, the outliers that are really important that you should know about. And then lastly, if you are really curious, I would honestly just consider reviewing the roadmap, which you can find at the Modular website. If we actually head over to the Modular docs here, you can go to roadmap and sharp edges, and you have some priorities here. So C and C++ interop, protocols, traits, just a bunch of cool things here to look over and stay up to date with. So now you should have all the tools in your belt to actually get started with, reading Mojo documentation, building your own projects, playing around with the language, and all of that fun stuff. So I hope you enjoyed the video. This tutorial was designed as a sort of beginner, emphasizing for beginners, people transferring from Python and trying out Mojo, as well as just some, concepts that you should be aware of when you're doing more advanced systems programming. So hopefully this tutorial was informative to you. Hopefully it helped. My YouTube channel is in the description below. So if you did want to check me out and maybe even subscribe, it's totally free. You can unsubscribe later, but I make pretty good content on there. So you might want to go subscribe. That's just in the description. So anyways, that's all I got. Have fun, my fellow Mojicians.